Well, hello everybody. Welcome to another AgileAssets Product Showcase webinar. We host these webinars monthly covering different products and services offered by AgileAssets. My name is Barry Raskin and I'm the Marketing Director here at AgileAssets. Today we're talking about and demonstrating how AgileAssets Pavement Analyst can help you get the most value out of your substantial investments in pavement assets. From the webinar, you'll learn how a pavement management system can help manage your pavement assets in the most efficient way possible, how AgileAssets Pavement Analyst allows you to optimize your pavement maintenance activities to meet your budget and level of service goals, and how advanced analytics in Pavement Analyst enables you to truly optimize your work plans based on multiple constraints and objectives. A couple of housekeeping items. This webinar is being recorded, and next week we will send a link so that you can watch the video and forward it also to your colleagues. The slides will also be provided when we send the link to the video. The presentation today will last about 45 minutes, leaving time at the end for questions. If you have questions, you can enter them into the Q&A window at any time. We will address them at the end of the presentation as time permits. At the end of the webinar, you will be offered a very short survey. Please take a moment to fill it in so that we can continue to improve these webinars going forward. Our presenter today is Eric Perrone. Eric is a Senior Principal Consultant at AgileAssets. He is a subject matter expert in pavement management systems. Eric has been with AgileAssets since 1994. During that time, he has implemented the AgileAssets Pavement Analyst system for 11 different clients, both within the United States and internationally, including such clients as Montana, Virginia, and North Carolina. His areas of expertise cover many of the AgileAssets management systems, including pavement, maintenance, and bridge management, along with leading project implementations and training. Eric received his Master of Science degree in Civil Engineering from the University of Texas. So with that, I will pass this over to Eric for today's webinar.
Thank you, Barry.
Eric?
Can everybody hear me?
Well, they're all on mute.
I'm hearing an echo, Barry. I think maybe you're echoing. There we go. Okay, folks, good afternoon. Again, my name is Eric Perrone, and I see from the attendee list, I certainly know some of you folks out there and others that I don't, but we'll be talking about the Pavement Analyst system today, going through some background information on some slides, and then we'll do a little demo of some of the software and discuss the kinds of things we have in the Pavement Analyst system. So to begin, some background on pavement management systems. First off, I think as many people know that investment in pavement assets by transportation agencies do represent a large proportion of the value in any given transportation system. Pavements represent a lot of invested money and work, and a big portion of any DOT's system. You know, historically, over a long period of time, programs developed to manage those pavements were frequently done by the best guesses of the practitioners. In other words, the engineers would make their best estimates of what to do and when to do them, and they would then apply the money and funding to get the work done on the pavements to maintain and rehabilitate pavement assets out there. Historically, there were no real mechanisms to evaluate the impacts of those judgments. In other words, it was hard to know whether or not things were being done in the right way and whether or not it was effective, nor was there any systematic way to compare different alternatives. Well, should we do this or do that, and what would give us the best outcome there? Well, pavement management systems try to change this. They try to bring some objectivity to looking at your pavement assets, They provide a structured system to objectively evaluate your paving programs. In other words, once you know what it is you're going to do, what can you expect from that paving program in terms of condition, in terms of the amount of money you need, et cetera. They try to utilize engineering information and judgment to project pavement condition into the future. So we try to look at what we expect to happen to our pavements as they age, and they are damaged by traffic and loading. They attempt to utilize economic analysis and optimization to choose the best approaches to investment. In other words, try to find the right treatments to do at the right time, so you can get the most or the best condition for the money that you spend. And then finally, they try to continually improve the process over time by providing a mechanism for capturing information on what gets done, what kind of work has been done, what kind of conditions are you experiencing, and try to allow you to improve your process over time. So the AgileAssets Pavement Analyst is an enterprise-level pavement management system, and that is we have a number of projects at AgileAssets. We have maintenance management systems, fleet management systems, bridge management systems, and the pavement management system is one component of that enterprise-level asset management system, and we like to think that it's an important component of those things. Our system provides a platform that allows you to do a number of things, but one of the things it does, and maybe one of the things that's not recognized very well, is that it is an area where you can collect and centralize pavement information and then disseminate that information agency-wide. So it is a web-based system. Everything can be pulled together in a database, centralized about your pavements, and then you can make that information available to users throughout an agency. It provides the tools needed to track maintenance and rehabilitation of the pavement, be it different types of treatments that are done, when they are done. You can track information useful for your agency about what kind of work was done and who did the work in terms of contractors or in-house forces, integrating with other maintenance management systems, and pulling in information done by in-house forces can be done. And then once you gather that information into a database, it allows you to analyze the impacts of your policy decisions. That is, you can do a lot of what-if scenarios and look at how you maintain your pavements is going to affect the condition you see in the future, affect the given budgets that you have, et cetera. You can optimize the allocation of your funding. You can do those what-if scenarios. Well, if I have this kind of budget, how should I be spending it? If I want this kind of condition, what kind of budget do I need? And again, you can continuously add new information to the system to help you in the decision-making process. We believe our pavement system provides, some of the most flexible and powerful analytics in the market. Powerful optimization engine that we'll go through and talk about today. So we have a lot of features we can bring to the table on that. These are some of our clients out there that's using Pavement Management System. A lot of our DOTs in the United States, and some of the biggest ones there. We have working with Texas and Virginia and North Carolina DOTs, some of the largest networks in the country, and also other agencies out there. So we have been implementing this system for transportation agencies throughout the United States and also in other places throughout the world. So we have a lot of experience with working with our clients and doing pavement management system implementation. A lot of good things to talk about there. Okay, so talking about the system in particular, this slide here is kind of a very, very high-level look at what the Pavement Analyst system looks like. Across the top, and maybe I'll get a little pencil here. Oops. Sorry. Across the top here, we have, let's see if I can, I'll do a laser pointer. There we go. So across the top here, we have input information to any given pavement management system. If you think about the types of things you might want to know about in a pavement management system, you have these types of categories of information. We have asset information, which is basic information about the pavements. You know, what county is it in, what kind of road is it, functional classification, et cetera. Information about the pavement sections themselves and what types of information you can get from them. Of course, you have information about pavement condition, and the agencies that we work with have all different types of ways of gathering pavement information, pavement condition information. There is, of course, standardized things like IRI out there, but then there's many different types of distress surveys, manual distress surveys, automated condition information. Different types of pavement condition information can be put into the system. Next, you also typically are interested in traffic. In other words, what types of traffic does the pavement serve? And that's useful for a number of different things. It's useful for performance modeling and knowing what kinds of loading the pavement is getting. It's also useful for prioritization. In other words, how important is that pavement and how much traffic does it serve? It's good in knowing the importance of the different roads that are out there. And finally, you want to know information about pavement structure. What kinds of materials are in use in these pavements? When was the last time they were worked on? What kind of work was done? Those types of information. So from a generic standpoint, these are really 4 major categories of information that are typically used in a pavement management system. What we do is we take that information from the various parts of the database and we go through what we call an aggregation process, which gathers that information together on a section-by-section basis, and we put that information into what we call the master files. And the master files are the kind of beginning point for the analysis portions of the software. So we gather that information for those 4 categories, pull it together, and then we put them into these places where we have it all in one place where we can begin to use it. That master file is the primary feeder of the optimization analysis in the system. And it is the beginning of the analysis portions of the software. Another portion of the analysis that's there is what we would call the engineering framework. The engineering framework is a configurable subsystem in the software that allows you to create performance models, decision rules and decision trees. In other words, under what conditions would I apply certain treatments, treatment definitions, which includes what kinds of rehab and maintenance treatments do you have available, and what happens to the pavement after you apply those treatments. And that becomes another critical component of the optimization analysis. Then you can run that analysis and use it to try to project what-if scenarios out into the future. And that, of course, gives you a number of outputs. You can get work plans, so the software can help to recommend projects to be done into the future. You can get projections of condition. So under those work plans, this is what we expect to see in terms of condition out into the future. And of course, you can get other reports and things out of the system. So from a very high level, this is what the system looks like. Now, of course, the devil is in the details. Every agency does pavement management slightly differently. And so there's a lot of configurability and things that you can do with the software. And from that standpoint, the software is very configurable. It's one of the things that we're very proud of. The Pavement Analyst database is not a fixed structure in that most agencies collect things in their own way. They use different types of inputs and outputs in the system, organized in a different way. And our database is able to be configured to store information, about pavements in a different way that matches agencies' business processes and how they work. It's really been designed to be flexible in that sense. And so the configurable components of the software, we can configure the different tables in the database, screens and windows, interfaces, imports and exports, conversions of data into the system. And finally, we've really spent a lot of time trying to make the configuration of the engineering inputs very flexible. And so we allow different types of condition variables, different types of performance indexes. The decision processes are all configurable through the front end of the software. performance modeling, and other things, estimating benefits of treatments and costs and those types of things. So we have a lot of configurability in the system that can be flexible to support many different agencies out there. Talking about pavement management analysis. Now, all pavement management systems generally provide some type of analytic capabilities. So if you go look at different types of pavement management systems out there, they all try to answer some of those questions. You know, well, if I have this much money, what should I do, and what can I expect to see out into the future? Many systems out there provide some basic ranking type analyses where they'll calculate some type of combined pavement performance index, PCI type of number that indicates the condition of the pavement. And using some type of formulas, that index helps to determine what should be done to that pavement. A lot of those ranking analyses out there are lacking in that they don't really consider treatment timing. They don't necessarily look at whether or not I should do a treatment now or later. And they also don't necessarily consider quality of service. In other words, how long is that pavement in good condition given this treatment compared to a project on another pavement? They're very much a ranking type of analysis out in the world there. Other systems out in the market provide some more robust analysis. They'll go through incremental benefit cost ranking and can consider some types of treatment timing effects and other quality of service comparisons. However, those types of ranking approaches can really only answer relatively simple questions. If I have this budget, what's my work plan? You know, single constraint and single objective type analyses. In Agile Assets, we provide many different types of analyses. We do provide those ranking methods where you can even estimate what we could expect in the future if we did a worst first approach to managing our pavements. This is usually helpful in showing people why optimization and doing things in a proper way gives you many benefits over time. You can set up prioritization formulas, and you can do incremental benefit cost analysis in our software. But our real claim to fame and our real approach to asset management and pavement management in particular is the true optimization that we have in the software. It allows you to analyze multiple constraints. It allows you to look at single and combined objectives and look at strategies across sections as well. And this is where we think that we really differentiate ourselves from everyone else out there. So let's talk about optimization quickly. You know, many different types of analyses try to attempt to answer that question. You know, well, what's the most cost-effective way to reach a desired service level, for example? So if this is the pavement condition I want to have over to the future, what's the most cost-effective way to answer that? Well, and many systems will try to answer that question using those ranking techniques. Well, those techniques aren't necessarily guaranteed to be optimal, number one. And number two, they really don't have a lot of flexibility in adding complexity to those questions. So for example, what if I wanted to add spending caps on different types of treatments while I'm trying to answer that question? What if I wanted to specify different performance levels on different functional classes? And what if I wanted to do all of those things at once? Our system can answer those questions directly. There's a direct way to set up those types of analyses, run the analysis, and get an answer out. Other systems either cannot answer those questions directly, or if they do, they'll require some type of trial and error approach where you put in a budget, see what your conditions are, put in a different budget, see what the conditions are, et cetera. And we think that's a pretty powerful way of looking at the software that's out there and how it goes. Okay, so that's in a nutshell, that's just a quick background of some of the things that are in the software and some of the things that we can look at. We'll kind of switch over into more of a demo now and talk about the actual software. I'll be showing some components of the software across different clients, using those as examples out there. But we'll talk a little bit about the database and show you some examples of the types of information and how we can configure the database. We'll talk some about engineering configuration and decision trees and those things that are important into the optimization and how you analyze those things. And then we'll talk about the optimization itself. We have a few kind of examples set up that just show the flexibility. And we'll talk a little bit about mapping and reporting to round out the demo. Okay, so getting into that, we'll start out with looking at the Virginia pavement system as an example of one of our state-level systems. I'm also going to show a little bit of stuff from the North Carolina system and a little bit of stuff from the Texas system, just to give a little flavor of different types of things that are out there. This is the home screen of the system. One of the things that I like to point out here is that everybody tends to have different types of information in their pavement management system. This is the information that was configured together for Virginia. They have information on bridges, median, road types, wet accident information. So this is information made available through the pavement management system to their users. One of the things that's important to remember here is that everybody tends to have their own data that they can make available. There's a lot of similarities in the types of data, but of course the devil's in the details. Everybody has their own different types of things. If we look at North Carolina, on the other hand, you'll see they have a different database menu here with different types of information available. And that goes for most of our clients. So our database structure is able to be set up to accommodate many different types of data and set up to import and use the information that you have as opposed to forcing your data into some fixed structure. So let's look at real quickly at just a few examples of the information that's available in a database. We'll start with pavement construction information. And I'm going to pull up the graph window used by Virginia to show pavement structural data that's out in the system. So I'm going to open up that window. What we are looking at here is actually pavement construction history information for Interstate 64 in Virginia, specifically around the Richmond, Virginia area. And what we're looking at here is a graph showing the layers here. So this is depth down the side and mile along the top, and we're showing the increasing direction. And if I scroll to the right, you'll see the different pavement layers represented here. If I click on a particular portion of the graph, on the right, I see a cross-sectional view showing the different lanes over here. And up at the top is a list of each of the layers that's available in the system. So this is showing us the different layers, when they were placed, what kind of material, thickness, et cetera. That's about that. If I scroll to a different portion of the thing and I click there, again, I see those different layers here. You'll see the different years. So these layers were done in year 2000, and then they have some other layers done in year 1991. So this provides kind of a clearinghouse of the construction history information available for the pavements. I can also look at, I can drill down into this a little bit if I want to, and pull up the actual data entry information. So when this information was entered into the database. And what we see here is all the information captured by Virginia about the work being done. So they have information about whether grinding or grooving or rubberization was done, et cetera. They have information about who reviewed the data entry here, et cetera. So they have a lot of information that they can capture. And this tends to vary from client to client as to how they do it there. But you can capture different information about it, about your construction history in the software. So this is just one example of the information you can capture. Of course, in any given system out there, you tend to also have pavement condition information. And so very quickly, I'm going to pull up the data on the asphalt condition ratings. So I'm going to pull up a graph window that shows us asphalt condition ratings in the database. And again, what we are going to look at here is, again, Interstate 64. We're going to look at the first 100 miles of Interstate 64. And what I have selected to show here is the IRI across a number of different years. So I'm just going to show data in graph here. And what this window lets you do is just compare pavement information down the road for different years. So I'm looking at 3 different years down there, the first 100 miles of this route. Again, one thing I want to point out is that the types and indexes and things that each client collects and uses can be different across our different clients out there. So we're able to configure these types of windows for each client without having to change our core code, without having to go into the actual system and make changes. These are all configurable elements that you can create and put into the system. And this is just showing a comparison of IRI across different years. And if I wanted to, I can come in and choose different miles here. Maybe I want to go between 10 and 15 and just show information there. You can come in and do that. And you can see a little bit more detailed information about the IRI changes on the road out there. So what we can do is create and configure a database that uses the information available from your agency and set that up. So that covers we also have other things about, you can put traffic data in there. This is information on how they create management sectioning, et cetera. So there's a lot of different types of ways to set up the system and use it out there. Okay, so that's a quick background on the database and database structures that you can create and use there. Next thing we want to get into is to talk quickly about engineering configuration. And really, engineering configuration, again, is something that's very different for different agencies. The needs of Virginia are different than the needs for North Carolina, which are different than the needs from Texas. So let's just look at a couple examples of what those look like. And let's start with, the first thing for us to look at is pavement treatments. And every client does it a little bit differently. But this is the list of treatments configured by Virginia for their analysis. And what you'll notice is that Virginia tends to do things on a kind of category basis. So we have corrective maintenance for different pavement types. So this is corrective maintenance for bituminous pavement types. Then they have preventive maintenance for bituminous pavement types. They have reconstruction for bituminous pavement types, et cetera. And what happens in this screen is that you specify a treatment at the top, and at the bottom you specify what happens to the pavement condition when that treatment is applied. So in this case, Virginia has an index they call the CCI, which is their critical condition indicator. It's kind of their overall index that they look at when they try to capture what's the condition of the network. And so when you do the treatment selected at the top, the CCI will actually improve to a 90 on a 100 down to 0 scale, et cetera. And so you have configurable elements here that you can set up how you want your treatments to be configured and how they'll look when treatment is applied. As a matter of just to show how things can be different from client to client out there, in North Carolina they have a different set of treatments. It's a little bit more detailed list of treatments here. So if I pull up the treatment list for North Carolina, you'll see that there's a lot of different types of treatments listed here. Here's an 1.5-inch overlay, and you'll see that their condition attributes, the condition that they track on their pavements, is different than that used in Virginia. The key is that you can specify the treatments and configure them to match the engineering practices that you have at your agency and put those into place. So there's a lot of different things you can do, and you can see the list of treatments here for North Carolina is quite a bit different than the list of treatments for Virginia or Texas out there. So the flexibility of our system to configure those things is wide open and able to be used out there. This is just a quick look at the kinds of things you can do for treatments. You can set up unit costs here. You can set up different types of cost functions. So if you have costs based on area, you can do it that way. You can have costs based on lane mileage. You can have costs based on pre-treatment condition, if you like, and so on. So there's a lot of things you can do with treatment configuration in the system. The next thing for us to look at in terms of engineering configuration is decision trees. And decision trees are, frequently used in pavement management systems to help identify what is an appropriate treatment to apply when a particular pavement is in a certain condition. And so this is our treatment decision tree configuration. In here, this is the North Carolina setup. They have a bunch of different trees, all their decision making broken out across different types of pavement condition things out there. So they might have a tree based on alligator cracking, relatively simple tree, so they're just looking at their alligator cracking index, and depending on the level of that, so I can zoom in here a little bit, depending on the level of alligator cracking, they might recommend different treatments that would be required there. And this is one approach to setting up the engineering configuration in there. In Virginia, just to show other types of things or other ways to do it, Virginia has a more coordinated approach. So all the information is added into a particular tree. So if I look at that, for their interstate bituminous pavements, this is what their tree looks like. And you can see that this is a little bit has a little bit more nodes and things in it. And if I zoom in on one part of it, we can look at that. In this case, Virginia is looking at what they call their load distress rating, and if it's less than a certain value, they're looking at reconstruction work. If their load distress is between two other values, then they look at a non-load distress rating. Then they look at IRI. They're looking at roughness on the road. They're looking at rutting on the road. And then they're also looking at what kind of work has already been done on this road in the past. So there's a lot of different ways of looking at your engineering configuration. One of the nice things about our system is that this configuration is not coded into the core code of the system. It is all configured through the front end. So if at a later time I want to come in and I want to change my tree, I want to go in and maybe put in a new decision node, I can add that. I can configure how I want that to work and put all of that in without having to go to AgileAssets and getting recompiled code or any of those things. The system allows you to make changes to that configuration going forward. I'm not going to save that edit. So that's a look at some of the engineering configuration there. We also have performance models in the system that can be configured to handle many different approaches to performance modeling. In Virginia, they use a particular power type model, but we're also able to use sigmoidal models and other types of models within the system, and you can see many different things out there in terms of how they go. This is just a quick look at, so the green line here is the projected condition for CCI over time for a particular family of pavements. You can do performance modeling for an individual section if you like, or you can do it for more of a family of pavements, which is pretty typical for what the agencies tend to do out there. Again, other clients, Texas has their own sigmoidal models that they've been developing for 20-some years, and we're able to use those models and pull them in. And North Carolina has models developed by UNC Charlotte, if I remember correctly, and they were able to pull those in and utilize them within the software. So we have a lot of flexibility in terms of how we set up the modeling going forward. Okay. So we have a lot of flexibility in engineering configuration. We have flexibility in terms of how we use data in the system. One last thing to bring up is the ability to choose and use different types of pavement attributes within the analysis that we have out there. And this window here is not very exciting, but really what it is it is a list of those attributes that are on your pavements, those things that are available in your database. And for each one of those, you're able to tell the software what you want to do with that element. For example, do you want to use it as a constraint in the analysis? Do you want to use it as an analysis scope variable? And what that means is, do you want to filter the analysis by that? So for example, I might want to sort this by that. I might want to, this is Virginia's district, so I might want to run an analysis just for one district, or just for one pavement type, or just for one functional class, those types of things. And there are a number of options here in terms of how you tell the software what you want to do with your information. This one here, decision variable, this just says what information in your database do you want to make available for creating and using in those decision trees. Which data elements will have a deterioration model, and so on. So there's a lot of choices here you can make about how you want to utilize the data available in the software for performing analysis and using the software there. Okay, so that's a quick review of the database and then engineering configuration. So let's just get into the optimization side of the world. This brings us into looking at the types of things you can do with the optimization. So what I have set up here in the Virginia system is just a whole bunch of small examples that show kind of the range of things you can do with the optimization out there. And the first one is what I would call just a simple budget analysis. And so when you do a simple budget analysis, the first thing you do is select an objective. And in this case, we have it listed as an objective what we call benefit. And benefit can be measured in many different ways, and clients do it in many different ways. But in many cases, what we like to do with benefit is look at, I'm going to draw a little thing here. If you have a performance model for an existing road that follows this shape, and at this point you apply a treatment to that road and it improves its condition to a certain level, and then maybe it follows a different performance model after that treatment is applied. Well, when we talk about what is the benefit of doing that treatment, what is the benefit you get by spending that money, it's typically some type of function of the area between these two performance curves. In other words, and if you think about the units of that area, it's a nice way of measuring what you get by spending that money. And for example, the bigger this area, the more time your pavement treatment lasts and the better condition it is over that time. And so those two components give a measure and a measure of how well a particular treatment does. And so in the analysis, when I put here, when I set benefit as an objective, I'm trying to maximize the aggregate benefit I get across the whole network given a certain amount of money that I'm going to spend, okay? So that's what we're doing here. So we are trying to maximize benefit, and in this case, it's just a simple budget. I just put in a $12 million budget for each of 5 years out there. And whenever you run an analysis in our software, the first thing you get, so this has been run, the first thing you get is an output work plan. So this tells you, based on the money that you've put in, where should you go and spend that money? And this is a list of proposed projects, each one with a particular location, a recommended treatment, an estimated cost, and a year as to when you should do that. So that's the basic output of the software. Given this objective and this budget constraint, this is the work plan the software would recommend to maximize the aggregate benefit across the network. The next tab here, Constraint Results, just shows you what the software did with respect to each of your constraints. So this is the actual amount of money it spent compared to your constraint. You see it spends right up to that limit in each of those 5 years. But then once you have that information, you can create and use different types of reports out there. You can look at different conditions in there, and let's see what we got here. If I want to look at what the projected, for Virginia in this case, it's what's their projected CCI over the next 5 years. You can see this is dropping, so evidently the money I'm putting in is not going to be enough to keep the condition up. So you can try different budget levels, you can try different constraint inputs and look at the effects of those settings as you go forward. Lastly, you can also set up a set of configured summary reports. In this case, this is breaking down that CCI index across different pavement types over the 5 years. I can look at what's the summary of how much money I'm spending on different pavement types. I can look at how much money I'm spending for different types of treatments recommended by the software, and so on. So there's a lot of different summary information you can create going forward there. So this is an example of one very simple scenario. And what I like to do is kind of keep going on these examples and add a little bit of complexity each time. So this next scenario is really the same kind of scenario. I'm still trying to maximize benefit, but now I've taken my budget. I still have $12 million, but now I've split that money across different functional classes. So I've said, well, I've got $5 million to spend on the interstate and $7 million to spend on primary roads. So all I've done here is run the same kind of analysis, but now I've constrained the inputs a little bit more, possibly to match maybe agency constraints or way your funding is done, or the way that the legislature might want to see, you know, et cetera. Those are types of things. Again, I get the same kinds of results. I get a work plan. I get constraint results, which shows me how it's spent against those constraints. And again, I get summary information that comes out of the software. It shows me what types of data we have available. That we go. Do we see some questions there, Barry? There, I don't know how to get the questions, Barry. If are they typed in or? Let's see. Well, I'll continue on, and then I think we'll have time for some questions at the end, and we can ask some more questions going forward. Barry, I don't know if maybe you can monitor those questions there.
Yeah, I'm monitoring the questions. Why don't we do them at the end of the? We'll do them at the end.
All right, that's great. Okay. So this is breaking down scenarios, breaking down your budgets across different types of functional classes. This one is now what I call overlapping constraints. Now this is where you can begin to do some more complex analysis. And in this case, what we're doing here is we're still trying to maximize benefit. We still have a breakdown of budget by functional class, but we are also requiring a particular percentage of the network must be better than poor. So in this case, you can set an upper limit on how much poor pavements you're willing to accept. And the software will analyze all of these constraints at once and output recommended work plans and output recommended data based on that. So what happens here is that you can mix and match different questions in terms of looking at what types of policies you have in place and how you want to spend your money. Again, the same types of outputs come out. You get recommended, you get performance indexes across different pavement types. All of those summary outputs come with each of the scenarios that you set up. And so what this allows you to do is be pretty flexible in terms of what kinds of what-if scenarios you can do and how you do them. Again, I'll keep going here. This is an overlapping budget, and so what this scenario, again, is trying to maximize condition given a certain budget. But now you'll see I have allocated $5 million for preservation treatments. I have allocated $5 million for the secondary roads in the analysis, but I've allocated $12 million total. So what I have here is a overlapping budget. So I have a $12 million total budget that I have to spend, but I have a cap on how much money I can spend on preservation treatments. I also have a cap on how much money I'm going to spend on my secondary roads. So you can start to mix and match those budgets to match those types of things you want to go out and look at. And same kinds of answers come out the other end. We get work plan, we get summary results, and so on. Just to get through some of these, we also have a way to analyze Condition requirements, excuse me. In this scenario, notice that my objective is now treatment costs, so we are trying to minimize our total costs. And in this case, we're trying to get our weighted average condition indicators to go from a 73 in year 1 up to an 80 in year 5. And so when you can now flop that question on its head and look at, well, how much money is it going to take for me to meet those goals? And this is the money amounts that it's going to take to go and match those goals. So you're able to set up these scenarios to ask a lot of different questions and do that kind of work. One more I'm going to show before we look at reports really quickly. This one here is also trying to minimize costs, but note that we're able to set constraints on the average condition of the network. That's this first line here. So I want an average condition of 85 in every year for the next 10 years. But I can also set distribution type constraints. So this next line says, I want 95% of the network to be better than a 40, and I want 80% of the network to be better than a 60. So I can throw these constraints in the pot and let the software choose projects that's going to meet those goals with the least cost out there. So I can go and mix and match across those different constraints there. And again, when I look at the constraint results, it shows me exactly what I'm getting from the analysis. I can do my summary graphs and summary reports and look at that information going forward. Okay, so in the optimization analysis, I hope we're getting across the point that we have a lot of flexibility here and a lot of ways to ask different questions of the software to get information out. That brings us very quickly to wrap up the demo, and we'll leave a little time for questions. The next things we want to look at is we also have some reporting available in the system, and I have a couple of quick examples of that to show. This is a report set up for Virginia where they configured a kind of a form-based report that shows condition information about a particular section of road. And so this is showing the first 20 miles of Interstate 64, my favorite road here. And it gives us all kinds of summary information that we configured for them. So this is, what kind of lane miles do they have? What does the pavement type breakdown look like? What kinds of treatments have been done on this road? So what was the last treatment category we know about? This is a breakdown of conditions. So what condition category is this road in? So you have 1.8 lane miles of very poor condition, and so on. So you have a lot of nice information gathered together in a simple report. This shows what kinds of recommended treatments are needed on that section. And then for each portion of that, so for each subsection of that road, there's some more detailed information, including the history of the condition, what the indexes have been over time, and so on. So this is a pretty nice summary of what those data looks like. So this is an example of a PDF report you can create. We can also look at some mapping capabilities here. I'm going to pull up Texas. Oops, put in my right password here. I'm going to pull up the Texas system and just show a quick example of a map that you can do with that. And then we'll open it up to questions. So in the Texas system, I'm going to pull up our GIS interface. And let me just get my map here. I've got a map coming up. This is a map of condition data plotted with projects out into the future for the Paris district in Texas. So this is just an area of Texas that we can look at and zoom in. And so the different colors are the different condition scores that they have there. The different dotted and other lines are what kinds of treatments are programmed to be done in the future. And so we're showing those two sets of information together. You can click on the map and see information about where you clicked and that type of stuff. We also have, once you've created a map and you like it, you can set it up in a layout, print that map out, and use all the information in your database to go and create that information there. Okay, so I think in a nutshell, I've been through the things I'd like to cover. I think let's open it up to some questions if there are any. And maybe Barry, if you have some listed, you can.
Yeah, the first one is, can you change the amount of funding per year?
Yes, you certainly can. In this scenario,
That's
yes,
all I
you
have.
can. Yep, you can set. Let me go to the first one here. I can always take this individual budget, and if I want to, I can split it out, one for each year. So now I have $12 million listed for each year, and if I want to edit one of those, I can go in and do that. So maybe I want to make this 15 million. You know, I can come in and edit that, maybe those 2 years in between, and so on. So you can take any of those constraints and you can make them individual for a particular year in the analysis as well. Okay?
Okay, another question is, for PPP availability projects, the penalties for overrunning work can be significant. Can the cost of non-availability be included within a scenario or weighed against the duration of the intervention activity?
I think I'd have to know more about the specifics there, but you can set the cost calculations for any given treatment, you know, very flexibly. So you can go in and set a calculation. Well, if pavement's in this condition, this is how the cost is going to come out. You can also set up your decision trees such that, you know, if you do nothing, well, it's not really a do nothing, but if you don't do this treatment, you have to do this stopgap treatment, for example, and that stopgap treatment can have a cost associated with it. So if I don't do what's required, I need to spend at least enough money to keep the road at a particular condition level. So there's a number of different ways you can set up those. I don't know that I'm answering your question exactly, but we do have a lot of different flexibility, a lot of different ways that we can configure the software to process that decision making.
Okay, another question. Under those constraints, can you subdivide the subdivision section also, i.e. year, functional class, and treatment, all by funding amount?
Well, what you can do is you can take any one of these lines, and if I want to break them down, there is a constraint subdivision here. And what those constraint subdivisions are is you can, let's see what we got here, looking at Virginia's. You can break any one of them down into further subdivisions. So if I hit this one here, now I've taken the $12 million I have in year one, and I now have 3 entries for each of the different types of pavements they have there. These subdivisions are actually trees. They look just like the decision trees. And so you could have a tree that is district and then county and then pavement type, or traffic level, or you know, the setting up of those trees is very flexible. So there's a lot of different ways you can break down those constraints, you know, depending on how you control the analysis that you do. So hopefully that answered the question. Barry, if you're talking, you're on mute. Barry, are you there? Okay. I think maybe did we lose Barry there? We may have. Barry, are you there?
Yeah, I'm back here now.
Okay.
One last question. Can you easily run sensitivities against varying material costs, say an increase in asphalt of 10% or of aggregate of 20%?
There's a couple of different ways you could do that. One way to do it is to set up different treatments with different cost factors. Another way to set it up is to set up different decision trees. In other words, under this decision tree, I'm going to use this treatment that has 10% more cost. Under this decision tree, I would use a treatment that has lower costs. Another way to do it is to have a cost table where you specify costs may be broken down by region or district or something like that, and you can edit the unit costs there, and the software will use them up. I believe, for example, in Virginia, see if I can find it here. Not sure where we set up their costs, guys. May even be in here. Yeah, here we go. In Virginia, they have a table that defines their unit costs, so you can go in and edit those unit costs, rerun the analysis, and see what you get out there. Okay.
Are there any more questions out there? Those are all the questions that have been logged so far. Are there any more questions? Please enter them in the Q&A tab. Well, I don't know that there's any more questions at this time, so we'll give you a few minutes back from your schedule, and we'll bring an end to this webinar. We want to thank you all from AgileAssets for attending. Please take a minute to fill out the short survey when you exit the webinar. It helps us so that we can improve the future webinars that we're producing for you. And finally, we look forward to having you participate in one of our upcoming webinars that we have scheduled monthly. So thank you all very much. Have a good day. Bye.
Thank you much.